Mercury, the closest planet to the Sun. A world bathed in searing solar light. By day, its surface scorches to over 430 degrees Celsius, hot enough to melt lead, hotter than the surface of a pizza oven. No atmosphere to speak of. No clouds, no wind, just relentless radiation and silence. A world you'd expect to be completely barren, utterly dry. A furnace floating in space. And yet, in the darkest corners of this blazing world, in craters where the sun has never touched, lies something we never expected. Not water, not vapor, solid, frozen ice. On the hottest planet in the solar system. How did it get there? How has it not melted in millions of years? And could it hold the key to human missions in this most unlikely place? This is the story of Mercury's frozen secret, a scientific paradox that defies everything we thought we knew. Mercury is a world of extremes. A scorched, airless rock orbiting just 58 million kilometers from the Sun. It's the closest planet to our star, and it shows. By day, its surface is baked to temperatures nearing 430 degrees Celsius, hot enough to melt lead. But with no substantial atmosphere to trap that heat, the warmth vanishes once the sun sets. Nightfall brings a plunge to minus 180 degrees Celsius, colder than any place on Earth. This stark thermal swing isn't just dramatic, it's violent. Mercury is a planet where fire and frost trade places every 88 Earth days. But here's where it gets stranger. Mercury has zero axial tilt. Unlike Earth, it doesn't lean toward or away from the sun. That means its poles, those jagged, cratered highlands near the top and bottom, never see sunlight. They're locked in perpetual shadow. And in that eternal darkness, untouched by sunlight for billions of years, something unexpected endures. Water. Frozen water. On a planet where water should instantly vaporize, or never condense at all, we've found ice. It's one of the most improbable discoveries in planetary science. And to understand how it's possible, we have to descend into the shadows, into the coldest, most forgotten corners of the hottest planet in the solar system. In 1991, radio telescopes on Earth aimed their beams at Mercury and saw something odd. The planet's poles reflected radar waves with an unusual brightness, as if something smooth and highly reflective was hiding in the shadows. Scientists scratched their heads. One explanation stood out: water ice. But the idea seemed absurd. Mercury, scorched by the sun, reaching temperatures over 400 degrees Celsius by day, was the last place you'd expect to find anything frozen. So the theory was shelved, set aside as improbable. Perhaps these reflections came from some exotic metallic mineral. Then came Messenger. Launched by NASA in 2004 and orbiting Mercury from 2011 to 2015, the Messenger spacecraft had the instruments to look closer. What it found rewrote expectations. The radar-bright regions aligned precisely with craters near the poles, craters that, due to Mercury's near-zero axial tilt, never see sunlight. These shadows are permanently cold, colder than even Pluto in some spots. Messenger's neutron spectrometer detected abnormally high levels of hydrogen, a clear sign of water ice, just beneath the surface. The reaction from the scientific community was a mix of astonishment and fascination. A long-dismissed theory had been vindicated. Water ice, on the hottest planet in the solar system, was real, and it was hiding in the dark. Mercury, a planet so close to the sun that its surface scorches at over 400 degrees Celsius during the day, seems like the last place you'd expect to find ice. And yet, in the most unexpected places, it endures. At Mercury's north and south poles lie vast craters, ancient, silent scars carved by cosmic impacts. These craters are no ordinary terrain. Because Mercury has almost no axial tilt, the sun never rises high enough to reach deep into these polar basins. They remain in perpetual shadow, untouched by sunlight for billions of years. These regions, known as cold traps, maintain temperatures below minus 170 degrees Celsius, colder than the surface of Pluto. With no atmosphere to conduct heat and no sunlight to warm them, these dark recesses become natural freezers, preserving ice against all odds. But there's more. Radar data and messenger observations suggest that this ice isn't always exposed. It's likely covered by a thin layer of dark organic material, perhaps delivered by comets. This acts like a thermal blanket, insulating the ice, shielding it from the sun's scattered rays and micrometeorite impacts. Mercury is a world of impossible contrasts. A fireball planet where, in the right shadows, the cold can be more intense than Earth's Antarctic night. So how did water, let alone frozen water, arrive on Mercury? One possibility lies far from the sun, in the cold reaches of the outer solar system. Comets, those ancient, icy travelers, may have slammed into Mercury during periods of heavy bombardment billions of years ago, seeding its surface with water. Some of that water, shielded by the deep shadows of polar craters, may have remained, trapped and preserved through eons. Another source could be asteroids, specifically water-bearing ones. Though typically rockier than comets, many asteroids contain hydrated minerals. Impact enough of them over time, and the planet could accumulate measurable stores of volatile materials. But even the sun itself might play a role. The solar wind, a constant stream of charged particles, can interact with minerals on Mercury's surface. In these reactions, hydrogen from the wind could bond with oxygen in surface rocks, creating hydroxyl compounds and eventually water molecules. Over millions, even billions of years, these processes could build up deposits in the most unlikely places, permanent shadows in Mercury's polar craters. And these findings do more than just surprise us. They challenge long-held assumptions about where water can exist and force us to revise our models of planetary evolution, especially in the inner solar system, where fire, not ice, was once thought to rule. Despite its closeness to Earth, Mercury remains one of the most difficult planets to explore. Its blistering heat, extreme radiation, and proximity to the sun create an unforgiving environment for both robots and humans. But the discovery of frozen water could dramatically change that. Water is more than just a life-sustaining molecule. For future missions, it could be mined as a resource, providing drinking water for astronauts, oxygen to breathe, and even hydrogen for fuel through electrolysis. These ice deposits, locked away in permanently shadowed craters near Mercury's poles, could become strategic outposts for scientific research or even deep space infrastructure. Could Mercury host robotic stations, shielded from the sun, nestled in ancient shadows, tapping into this frozen treasure? It sounds ambitious, but it mirrors current plans for the Moon and Mars, where locating and harvesting ice is a top priority for future missions. If humans ever establish a presence closer to the sun, these cold traps could serve as vital stepping stones, a paradoxical oasis on a scorched world. Mercury, a planet scorched by the unrelenting sun, its surface hot enough to melt lead. At first glance, it is the last place in the solar system where one would expect to find something as delicate, as fleeting as ice. And yet, at its poles, hidden within the eternal shadows of ancient craters, frozen water endures. This stunning paradox forces us to rethink the boundaries of possibility. It reminds us that in planetary science, certainty is often the enemy of discovery. The cosmos does not bend to human intuition, it defies it. We once thought water could only persist in places teeming with warmth and shelter. Now, we find it lurking on an airless world just a stone's throw from the sun. Mercury, far from being a sterile, forgotten rock, is a vault of secrets, one that still holds clues to the solar system's earliest days and to the forces that shaped every world we know. Perhaps the most profound lesson is this: in our search for understanding, it's often the harshest, most unlikely places that reveal the deepest truths.